Well, good afternoon and good evening, and welcome back to the Johnson Space Center for today's mission status briefing on the progress of Endeavour's flight to the International Space Station. The crew on board has been together now jointly since early this morning, and here to talk about it is Lead Flight Director for STS 97, Bill Reeves, and also joining us is International Space Station Flight Director John Curry. And we'll hear from both gentlemen and then throw it open for questions, and I'll turn it over to Bill.
Okay, good afternoon. With the joint operations today, we're rapidly closing out an absolutely flawless mission. We've accomplished all of our objectives now except for the fly-around, undocking and fly-around, which we're going to do tomorrow. And crews are working together extremely well. The vehicle is performing very well. The shuttle, we're not working any anomalies. We should be in great shape for undocking tomorrow and then the packing up and getting ready to come home on Monday. We've already started looking preliminary weather and things for Monday. Of course, it's a little far off yet, but weather opportunities do look good in the long-range forecast for Monday. A few of the times for the undocking activities tomorrow, we will be doing the undocking at a GMT time of 19 hours, 13 minutes tomorrow. We will undock and do the full rev fly around that was planned pre-flight. The only difference is we will not be doing the slight attitude adjustment we were going to do during the fly around for the IMAX photo, because the payload bay IMAX camera has failed and will not be available. But we will be getting some awfully good pictures, and we are setting up the lighting so that we will have a great photo opportunity during the fly around and a good inspection of the station as we fly around it. We then, let's see, the activities today included, as I said, the transfers. We did perform the DTO, or Detailed Test Objective, what we call 261 test, which is a structural modeling test where we collect data after we fire the primary jets on the shuttle in a specific sequence so that we can observe the dynamics in the station. That test went exactly to script, and we completed it. We were able to get the centerline berthing camera system set up. We did conduct a complete video test between the orbiter flight deck, in fact all the way to the ground, between the ground, the orbiter flight deck, and through the centerline berthing camera system that was installed in the node for the lab berthing on the next shuttle flight to the station. And that system worked perfectly. It was a great picture. We did get the floating potential probe set up in the node, and it is working perfectly. We have already started collecting data, and we can see that the plasma contactor units are clamping the voltage between the plasma and the station as was hoped and predicted. It's working perfectly. We're seeing very low numbers. Let's see. All of the transfer ops were complete, or they were winding them up as I left over there. We expect to leave the hatches open tonight, and the crews will be able to have some private time until the station crew goes to sleep, and John can get into that in a little more detail about what will happen on the station side. And then we will close the hatches out in the morning in preparation for undocking and do the leak checks, and then undock, as I said, at the time I gave you. After we undock, we do the fly around, and then the rest of the day is just preparing to get ready for entry and landing and get a leg up on getting the vehicle stowed. So it's been a great mission. It's outlived all of my expectations, although we expect every mission to go per plan. We did have some challenges along the way, but we had great teams working all of our problems. We worked our way through them, and as I said, everything is totally successful. I can't compliment our flight manager, Denny Holt, who worked this mission from the shuttle program and put it together. It's one of the cleanest flights I've ever worked in terms of of everything being in the right place and loaded properly and not having any trouble finding anything. Everything was right where it should be. Ron Torsivia was our was the launch package manager from the Space Station Program Office, who worked this flight with me as lead flight director and with Jeff Hanley as the Space Station lead flight director. And things have worked out extremely well. We're very, very pleased with the flight. So let me pass the microphone to John Curry, and he can tell you the activities that took place on station today.
Well, thank you, Bill. To be honest, I don't think I have to summarize the activities that went on station today because we got a lot of help from the shuttle crew today. It was very surreal, very satisfying to actually see both crews working together and working the transfer plan, working the centerline camera checkout, working the floating potential probe installation. All of these were station activities that, because the station crew has been spending a lot of time trying to work some of the onboard system problems they've had recently. Most importantly, the air conditioner that broke earlier this week and the VOSDUC system, the carbon dioxide removal system things. They were a little bit behind and somewhat behind in the packing plan. And of course, today was the first day that we had both crews together, and then tomorrow was undocking. So that didn't give a whole bunch of time for getting all that taken care of. And the shuttle team pitched in immediately and helped out with getting Shep and Sergey and Yuri caught up. And obviously, if anybody just saw the press conference, they're very thankful for that work that the shuttle side did. Again, prime example of how well this the station works with the integration of the teams between the shuttle and the station. That said, Bill and his team, he was just thanking a lot of people for the hard work there, and Bill Reeves deserves a lot of the credit for how well things have gone, and Jeff Hanley, who is the lead for the station side for us, has done a tremendous job working all this together. And all of the flight controllers that we've worked, and the integration with the Moscow team, it's almost mind-boggling to me that this mission went this smoothly, because going into it we knew there was going to be complications because we had two crews separated by hatches. We had 3 different control centers, both the one here in Moscow, then the Space Station Control Center here, and then Bill's team there in the Mission Control Center, what we call the White Vicar, where the shuttle is controlled from, and all that has gone spectacularly today. All of our mission objectives have been met up to date, and I think we're ready for undocking. Just to give you an idea where the station crew is headed here in the future, obviously, as Bill said, the transfers are still ongoing, and then shortly here we're going to be putting the station crew to bed because they still go to bed before the shuttle guys. After that, they will be waking up at about, I'll give you times in Houston time. They'll be waking up about 2:30 in the morning, Houston time. Their major activities in the morning is more of the packing work. This is even before the shuttle guys get up, and they've got an activity about 3 to 4 hours scheduled for the air conditioner I was talking about earlier, what we call air conditioner unit number 1. Its power supply failed, and we want to bring that home and have the Russians want to take a look at it, see what was wrong, possibly refurbish it and put it up on a subsequent mission. So they're going to remove that from the air conditioner, and we're going to bring it home on the shuttle. So they're going to be working that in the morning. Then the shuttle crew will wake up and have lunch, and we'll head towards the undocking. Hatch closure, just to give you guys, I don't think Bill stated that one, so I'll tell you when it is. It's somewhere around 10 a.m. Houston time tomorrow. And then we head into undock and the fly around. And I've been waiting for this, not so much as a flight director, but more as an observer. I cannot wait to see the station with the Earth in the field of view. I think it's going to be pretty impressive seeing those P6 solar arrays. They're ready to go. The other items for the future that our team is tracking still, in addition to the shuttle activities and heading for undocking, is there has been some discussion going on with the Russian side, pretty heavy, about what we're going to do with the Progress, since it is still loitering and waiting for a potential redock opportunity. We tentatively have that scheduled for Christmas Day. That's mostly because of lighting conditions to optimize the probability there. What I feel pretty comfortable that we're going to do for sure is that on Christmas Day we're going to bring the Progress back to the station keeping distance, just to verify that the Coors is in fact working with the patch that they put on there. That's the key mission objectives of that. And then we will have a second set of criteria that we look at to determine whether we will press with the final redocking. The date, I'm saying Christmas Day now, that may still be up for debate because we on the American side would probably prefer that that go somewhere else. But if lighting is the right place to do it that day, then we will. I think that's all I had to say right now, other than, like Bill said, I am watching the hatch opening today was quite a pleasure to have been a part of something so spectacular. That's all I had.
Okay, thanks, John. And we'll take questions from Mark and then see if Kennedy has any questions.
Mark Carruth from the Eastern Chronicle. I just had one question, and it just regards the hatch protocol for the overnight. Are you leaving it open primarily so the two groups can socialize? And if so, how free are they to rest, sleep, dine, talk one place or another? What are the ground rules if you had something where they had to go back to the respective ships?
Well, it's we didn't want to get into the hatch closures and things in the middle of the post sleep and everything, but the primary reason is to keep the vehicles open up to each other if there are any I forgots or anything's going on. But the crews have a scheduled sleep period, but it's kind of like putting your kids to bed. You can tell them what time to go to sleep, and you can close the door to the bedroom, but what goes on is kind of up to the crews. Our main objective is to make sure that they get enough sleep to perform their duties tomorrow, and they deserve whatever time they get together.
Is that it? Okay, let's go to the Kennedy Space Center for questions there, please.
This is Steve Seislaw from Florida Today. We found out today here about an aft separation bolt on the SRB that did not fire. I'm wondering, realizing that you may not know the details of that, I'm wondering what would happen during a launch if one of those 4 bolts did not separate.
Well, in the first place, the system is redundant. It's redundantly designed for that very reason. We don't need to what if to the catastrophic failure. We have enough redundancy in the system to where that's not an option. And the system did perform. The redundant system did fire the bolt. I just became aware of it right before the in-flight press conference today, and in fact there was a question to Brent Jett today on that, and we hadn't even told him about it because we just got the information in the control center. I think they found it last night at the Cape when they were going over the SRBs that they had retrieved. And the bolt does have redundant initiators on it, and it's a bolt that can separate from either end to separate the strut. And the way I understand it, and I don't have all the details yet, is that one initiator didn't fire and the other one did the job. So that's enough said at this point. There will be a thorough examination of it and analysis of it to determine why the one didn't fire. But the redundant system did perform its job.
What was your reaction to the news?
We take it in stride. It's we've seen failures in systems before that we have backup systems that have taken over in my 30-some-odd years of working here. But that's exactly why the systems are designed the way they are.
This is Phil Chen, Earth News for John Curry. How long is it going to take to get the Alpha crew back onto their normal wake-sleep cycle, since these visitors were like normal holiday visitors, disrupting everything and messing around with everything?
Well, Phil, we never actually on paper changed their sleep cycle, so I imagine they're going to head right back to their normal sleep cycle this coming night after undocking. They have been staying up later, and like Bill said, you just can't help it. There's, with spacewalks going on and those kind of things, even if they're not playing heavily in there, I don't know this for a fact, but I can imagine that they were probably watching a lot of those activities. And it's probably a lesson learned that we'll look at in future missions and try to optimize the sleep cycles to be co-aligned as much as they possibly can. Specific to this mission, now that the 4A mission is over We do want to try to give this crew a break. They have done an excellent job. The station crew has done an excellent job of getting that vehicle in the configuration that it's in now. It's in great shape. Now that we've solved the air conditioner problem and the carbon dioxide removal problem, I think we'd like to slow the pace down a little bit, and hopefully that'll help with the sleep cycle adjustment.
And with the Progress, my understanding is there's actually two different scenarios, one where you do a close approach with the Kurs, but don't do any further than that, and the other one where you actually use, from that point, take over the Kuru. And does the software with the Toru have fail-safes put in place that if for some reason it loses lock with the space station or something like that, that immediately pushes it backwards away from the space station rather than continuing the last command or something like that, to ensure that we don't just have a scenario where you lose radio lock and have a bad day?
Okay, let me see if I can summarize the situation as much as possible. You're correct. There's two separate objectives going on here. The prime objective of the Progress 2 reapproach is to verify that the Kurs system, the Russians discovered a known configuration problem in the Progress software, where when it's the way we approach when we do dockings to the FGB nadir port, this is unique to dockings to the FGB nadir port, you first, when you're coming in from the far field distance up to the about 250 meters to the station, you get to that 250 meter point, and then station keep when you're locked on the service module arrays. All of that is working nominally. There's nothing wrong with that whatsoever. It wasn't the last time. Where they had the problem was when they transitioned from the service module Kurs system, the automatic rendezvous system, to the FGB system. The station was fine. What was happening was that on the Progress software, they had reversed two sequences where it started to look for angles data on the FGB Kurs before it actually locked on this target signal, and so it got confused. It was assuming it needed lock for the angle data to work, and so it was not successful. They've since fixed that, at least on the ground. We have not uplinked the patch to the Progress yet, and so they're doing a lot of testing on the ground to verify that it's accurate, and then they want to test that for a subsequent docking to verify that any future progresses that we might put, or the docking compartment which is supposed to go up there, that we understand the software and that the FGB nadir Kurs will function perfectly. All of that is very safe. There's no real risk involved in that because it's exactly as it was before. So what they will do at that point to verify it is they send a command, the ground will do this, to send the command to initiate final approach. And at that point, the vehicle then translates laterally from the SM arrays over to the FGB arrays. It's about 25 meters distance, so you never actually get any closer. While that's going on, they're verifying that their data is good. And so that then will end the requirements for the first test sequence. Once that's complete, then you decide what you do from there. And to answer your question on the Toru, which is the manual docking, the way that the Russians, the crew would have to dock to itself, because we pyrotechnically fired one of the antennas required for the auto docking from 200 meters on in, we have to go to Toru. So the crew would then, we've got a set of criteria we're building, we're going to put into a flight rule before we come into this day that says, if the camera, which had blur on it the last time, shows a blur again, then they will abort the sequence. And there's multiple ways to abort that, the final approach. It can either abort itself if it doesn't get a signal within a certain amount of time. The crew can send the abort command, or the ground can send the abort command. So all of that is again, nominal software. There was no changes to that piece of it. So the only piece we'd have to deal with is the decision on whether to go ahead and have the crew perform the final approach. And the major criteria will be the Progress camera that had some water on the inside of the lens that formed on there and caused a blur. We would not want to attempt redocking for that if that reappears.
Okay, and since you haven't had the Progress dock for a week or so, what kind of trash are you sending away on that garbage scow that's going to undock tomorrow, and how much trash altogether?
Well, Bill, I don't know if we know. You're talking about the shuttle.
No, you're talking. I thought you were talking about the Progress. Are you talking about the shuttle?
He's talking about the shuttle.
Because there's no, you don't want to keep it on space station.
Yeah, there is a certain amount of stuff that has been transferred over. Bill probably knows the details better than me that we have in fact transferred over to the shuttle side. I don't have the total volumetric or size or weight of what has been transferred. Some of it's garbage, some of it's useful stuff. Bill?
Yeah, we're bringing back, as John mentioned earlier, some of the components that had failed on the station to be brought back for analysis. We're bringing back, well, we can provide you with a complete transfer list of everything that's coming back.
But Phil, let me try to answer the question differently. We packed the progress before undocking with the assumption that it wasn't coming back, and we put most of the trash in there. Most of the items being transferred to the shuttle is useful things we want to get to the folks on the ground so that they can analyze it.
Todd Halverson of Space.com. Bill, just to clarify on the situation with that pyrotechnic device on the strut. There's one explosive charge on or cartridge on either end of that strut, and the firing of either of those would result in a clean separation. Is that correct?
That is correct. That's the way it's designed. The strut has a bolt, a pyrotechnic bolt, that frangible bolt that holds the strut together with a defined separation plane, and the initiators are on either end of this frangible bolt. So if either end fires, then it's a clean separation.
And if the initiators on both ends fail, is that a Crit 1 mission failure scenario?
I believe it is, but all of the circuitry is redundant as well that fires the initiators. So, but it is a Crit 1 system, yes.
Steve, Sislaw, Florida Today, again. This time for John. I may have missed the comment earlier, but what was the meal that the two crews shared today? What exactly did they eat?
You know, to be honest, I have no idea what it was that they shared at the meal. Do you know, Bill? I don't know. We weren't taking TV down at that time, so I'm not sure what they were eating.
Okay. Also for John, Shep mentioned during the press conference that sometimes the ground doesn't appreciate the work they're doing up there and vice versa, the amount of work. I'm wondering if that's more of a Russian ground problem or on the American side.
I think it's our problem. I think it's a joint issue. And I think, well, you know, the comments you're talking about, right after that, Sergei mentioned that it's not that we overbooked. And I do think it's joint. It's not just the Russians. We're all working to build a plan together here that's useful, and we just have under budgeted. And a lot of the activities were on the Russian side initially, just simply because they're doing. It's a brand new vehicle, and you're having to install major pieces of hardware like an air conditioner, and sometimes the budgeting of the time was not sufficient. Some of it is beyond our control. For example, a simple load of today, actually one of the shuttle crew members, Carlos, loaded they have Windows 95 on some of the laptops on board. Most people can appreciate this, and they were loading in Windows 98 today because we wanted the software that was needed to operate the floating potential probe software that Bill mentioned. We needed Windows 98 to be loaded. It turned out, for whatever reason, with that disk, it took 2 hours to get that software loaded. Those kind of things, you know, is hard to account for. But we learn lessons on how to do these things, and then the next time they come around, we budget better time. So 2 hours is what we're going to budget for the next time they're doing loading of software.
This is Stefano Corridon with UPI Popular Mechanics for Mr. Reeves. Is it correct to say that one initiator failed and the other one worked, and that's the one that started the separation of the booster?
Well, the mechs or the controllers that fire those pyros on all of the struts at the same time when it's time for when the SRB burns out, the solid rocket booster burns out, and the command is sent to separate it from the external tank. It fires all of the struts, and it fires all of the initiators on both ends of all of the bolts that hold all of the struts together. And so it's a totally redundant system. I guess I don't understand your question, but it did, it does fire both initiators at the same time.
Okay, the question I was trying to ask was, did one initiator fail?
It's my understanding one failed. How it failed, whether it didn't get the electrical signal, whether the initiator itself didn't fire, I have not seen any data yet on that. And I'm not even sure they've got the system apart enough to know that.
This is Phil Chen again. John, any concerns that you're down to 1 SKV now, and that if it fails, you don't have any way of removing most of the humidity? And are any of the broken parts coming back on the shuttle?
Well, I think it's a flight director's job to be concerned. I mean, that's one of those things we always keep track of. It's a loss of redundancy. Right now we're down to 1 air conditioner, and therefore if we lost that air conditioner, we'd have to deal with it. And of course we're always working resupplies. That's why that progress that's out there, we have other progresses that the Russian side could potentially provide for bringing up spare parts. And then obviously we also have the shuttle. Now it'll be Mission 5A, which delivers the lab, and those kind of things are all worked in a well-orchestrated manifest plan that talks about how much redundancy you need to have on board the station. The lab provides a lot of other things that will give us additional redundancy as well. So the question would be, how do we get between this shuttle flight and the next shuttle flight and make sure we don't have any issues? We always track how much carbon dioxide removal capability we've got, how much oxygen production capability we've got, how much humidity removal and temperature control capability we have. It does turn out this particular air conditioner that we have operating now is operating better than the first one ever was, and I guess it turns out it's because that one had a power supply problem, so we want to get it fixed. It's a loss of redundancy, and we will watch it.
Okay, but is that failed power supply coming back on the shuttle, and any thoughts about shipping up a replacement power supply on 5A if there's enough margin available?
It'll either be 5A or a progress mission, like I said. We are, in fact, bringing it down. That was the part I was mentioning tomorrow, that Yuri and Sergei are scheduled for 3 hours to remove that power supply from the air conditioner that has the bad power supply. They're going to remove that tomorrow, give it to the shuttle crew to bring home so that the folks in Moscow can refurb it, verify what happened with it, because that's also important, because you don't want to put up another one that just doesn't work either, and then get us the redundancy back on a subsequent mission. And then the trade-off would be, do you just bring up the power supply or do you bring up a brand new air conditioner? That's still to be determined.
And as far as LIHO is concerned, are the shuttle giving any of their excess canisters? If so, how many, and how many man days supply would they give you?
I think
we were giving them 1 for sure, and possibly 2. We were going to wait until in the morning to make our final decision on the second one, but it looks like at the most 2 that we will give them.
Yeah, it was a good thing that we were able to fix the Vozduk system in advance, because we thought we were only going to be able to transfer 1 LIHO can, and then when the carbon dioxide removal capability increased on the station, shuttle didn't have to take up the slack so much, so it looks like it might be 2 cans.
Todd Halverson of Space.com with one more initiator question for Bill. Could you give us an idea of the reliability of these initiators historically? How unusual is this situation?
Well, it's the same basic NASA standard initiator that we've used in the program clear back to the Gemini program, as far as I know. We've used this through Gemini, Apollo, Skylab, Shuttle, and now into the space station program. And the initiator itself is a small charge that's electrically fired, and then the initiator goes off and builds up a pressure inside of a frangible bolt that then shatters and separates physically. As I said, it'll take an analysis of what this particular failure was to find out exactly what failed. We do not know at this point, at least I do not know at this point, again, whether it was an electrical failure in the system, and there may not be anything wrong with the initiator at all, whether it was the initiator itself, or even whether the initiator fired and then for some reason the frangible bolt didn't fracture. We'll just have to wait till the analysis comes back and see.
But historically, how reliable have these standard initiators been?
They've been very reliable. I think I can vaguely remember that maybe we've had a few failures in some of the past 4 programs, but I can't. And I'm sure that research will go on in the data research. We'll go back and look at it. But it has been a really reliable system. For sure, I can tell you we've had no catastrophic failures as a result of these things.
Steve, Sislaw, Florida today. For Bill, a non-initiator question actually. I was when you replay this mission in your mind, what are the highlights, and how would you explain it to friends and family, say over Christmas dinner?
Well, I think the real highlight is what we're all going to be able to appreciate and be able to look up in the sky and see this thing, see the space station Alpha go over, and as one of the, I think they say the 3rd or 4th brightest object in the sky. And you'll be able to look up and see that thing, and we can all take great pride in the fact that we had something to do with that and to make that possible. And then in the future, we'll continue to be able to take pride in all of the results that we get from the space station as it gets fully functional, and we're able to get some real science out of the station, and who knows what we'll get from it.
Okay, we're done at the Kennedy Space Center. We're back here. Mark, you have any follow-up? Juan? Okay, a couple of quick programming notes. Flight day highlights tonight at 8 p.m. Central Time, 9 o'clock Eastern Time. The undocking, as Bill and John mentioned, is set to occur at approximately 1:13 tomorrow Central Time, 2:13 in the afternoon Eastern Time. Our next opportunity to get back together for a mission status briefing is at 3 o'clock tomorrow afternoon. Of course, that's hinges on the undocking and fly-around activities. And Houston will get a beautiful view of the station and shuttle tonight at 6:28, so a little less than an hour from now. And folks around the country should check the spaceflight.nasa.gov website for sighting opportunities in a city near you. And it ought to be pretty spectacular with those new arrays. So with that, we'll bring the briefing to a close, and we'll head back to Mission Control and back to space. Thanks.
This is Mission Control Houston at a mission elapsed time of 7 days, 20 hours, 28 minutes into the flight of Endeavour to the International Space Station. As it has been docked to the station for the better part of the past week, Endeavour and its 5 astronauts, Commander Brent Jett, pilot Mike Bloomfield, and mission specialists Joe Tanner, Mark Garneau, and Carlos Noriega, are wrapping up their work with the Expedition 1 crew of Commander Bill Shepard, flight engineer Sergei Krikalev, and pilot Yuri Gudzenko aboard the International Complex, following a full day's worth of activities since hatches swung open 9 hours ago at 8:36 Central Time this morning for that first handshake in space between Commanders Jett and Shepard. The station shuttle complex is about to cross the equator, moving from northwest to southeast across the Indian Ocean at an altitude of 236 statute miles, and orbit inclined 51.6 degrees to either side of the equator. The crews, as mentioned in the mission status briefing just completed, wrapping up a full day's worth of joint transfer work. The items that were transferred over included computer equipment, spare parts, clothing, fresh food, and additional bags of water for use by the expedition crew members, Shepard, Gudzenko, and Krikalev, who will be aloft until February, when they're scheduled to be replaced by the next expedition crew, consisting of Russian Commander Yuri Usachov and his U.S. crewmates Jim Voss and Susan Helms. The 2 crews will go into staggered sleep schedules this evening. The station crew scheduled to begin an 8.5-hour sleep period in about 24 minutes or so, just after 6 p.m. Central Time, the shuttle crew will begin its 8-hour sleep period just after 10 p.m. tonight, to be awakened just after 6 a.m. on Saturday morning to begin final transfer operations that will culminate in the final handshakes between the crews, a final farewell, and the closing of the hatches between the Unity module that the crews have been working in for the better part of the day, along in the Zarya and Zvezda living quarters of the station. The hatches will finally be closed between the Unity and the docking adapter tunnel leading from the station to the shuttle itself. That hatch closure just before 10 a.m. Central Time on Saturday morning, setting up the undocking of Endeavour from the International Space Station at 1:13 p.m. Central Time Saturday afternoon. The undocking will follow a fairly familiar course, except it will be done basically in reverse of what has been done in the past, where pilot Mike Bloomfield will be at the controls. He will send commands to unhook the hooks and latches that are hooking up Endeavour's docking mechanism to the docking port, the earthward-facing docking port called Pressurized Mating Adapter number 3 on the International Space Station. He will begin to back Endeavour away from the station as it flies in a basically a horizontal configuration to the Earth in the so-called velocity vector, with the Unity module facing the direction of travel. Bloomfield will back Endeavour away to a position about 400 feet below the station, and then he will initiate a one-orbit or one-lap fly-around of the station at a radial distance of about 400 feet or so. It's a tail-forward maneuver that Bloomfield has rehearsed for the better part of the past year. That will result in some spectacular imagery of the International Space Station with its gold and blue solar arrays spread 240 feet from wingtip to wingtip, with the Earth in the background. After about a 45-minute fly-around, again a one-lap fly-around is planned. Bloomfield will fire jets for the final time at 2:16 p.m. Central Time, and that will send Endeavour on its way in a final separation maneuver from the station, leaving Shepard, Gudzenko, and Krikalev behind to continue their work, setting up the station for the holidays and for the arrival of the next shuttle crew aboard Atlantis in January on the mission to deliver the U.S. laboratory Destiny to the international complex.